Hello viewers, welcome to Quick Coder. My name is Tulsi. Today's topic is finding the next greater element on the right side. Okay, so let's get started. Okay, so let's discuss about the next greater element on the right side. So given an array. So what is the next greater element? Okay, now let us find. For example, if we are here, so we have to find the next greater element. So after 4, we have two greater elements, 5 and 25. But here we have to print the next greater elements, means immediate greater element on its right. So immediate greater element on its right is only 5. Now when coming to 5, so 2 is less than 5, okay. 25 is greater than 5. So we can write 25. So after 2, the immediate greater element is 25. After 25, there are no elements, so we can write -1. So coming to here, when we are here 13, the next greater element is nothing is there. So we have to bring -1. So if we are here, so the next greater, immediate greater element is 12, not 6. For 6, it is 12. For 12, again it is -1. So how can we implement this? Okay, let us, like this can be implemented using brute force solution also, like traversing one element. So we can write the two inner loops. The first inner loop is we are at here, and at second inner loop, we are traversing from here to here, and we are finding whether this element is greater than this. If it is greater than this, then we are printing and we are stopping the loop. So this is actually O of n square solution. So we are finding for the better solution, which costs only O of n. Okay, now let me erase this all and let me conclude a beautiful solution for this. Okay, now see here, for example, I'm using a stack. So using stack, we can implement the solution with only O of n time complexity. So how can we do this? For example, here using this stack, I'm actually traversing from the last. See how I'm completing the solution. So for example, if I am in 25, I'm traversing from the last one. So first of all, 25, what I will check is there anything in the stack or not? There is nothing in the stack. So in the output, I will print -1. Then I will push this element into the stack. That's fine. And again, now I am here. Now I will check if my stack peak 1 is greater than 2 or not. Yes, stack peak 1 is greater than 2. So I will print 25. So what is there in the peak? I will print 25. Then I will push this 2. So every element will be pushed. There is no condition for that. Now I am here. Now I am at 5. So 5, first of all, I will find is my peak element is greater than 5 or not. No, my peak element is not greater than 5. So I just pop the element. Now again, I will check is my peak element is greater than 5 or not. Yes, my peak element is greater than 5. So I will print 25. Then I will print 5. And again, now I am here. So at 4, first of all, what I will do is my peak element is greater than 4 or not? As peak element is greater than 4, so I will just print 4. Then I will push the 4. So this is the simple solution. Now come to here. So first of all, what we are doing, we are just taking an empty stack. Now we are here now 12. So is my stack is empty. So nothing will be there. Just print -1. Now push the 12 into the stack. Okay, now I am here. Now I'm checking is my peak element is greater than 6 or not. Yes, peak element is greater than 6. Now what I'm doing, okay, what is the peak element? 12. I'm printing the 12, then I'm pushing 6 into the stack. Now I'm at 7. At 7, is the 6 is greater than 7? No, just I want to pop it. Now again I will check is my 12 is greater than 7. Yes, 12 is greater than 7. So printing 12 and pushing the 7 into the stack. Now I am at 13. 13 I will check first of all the top element is greater than 13 or not. No, 7 is not greater than 13. So I will pop element. Now again I will check is my 12 is greater than 13 or not. No, my 12 is not greater than 13. Again pop it. Now again I will check is nothing is there. So if stack is empty, then we just print -1. So this is the simple solution which actually takes an additional space but only O of n square. Okay. Uh, but only O of n time complexity. Now let's start coding this. Okay, now let's start coding. So is it recording or not? Yes. So first of all, what I'm doing here is, so I have to implement a function here. and I want to return a long array. Okay, I will take like long, I will take it as result is equal to new long of size. They have given n assets, so n. That's fine. Now what I want to do, I want to take a stack now. Stack of long yes p is equal to new stack. Okay, I have created a stack. Now what I want to do, so as we already know, for last element the next greater element is always minus 1. So what I will do is a result of n minus 1, sorry, n minus 1 is always minus 1. That's fine. And now I will traverse from the second element from the last, means I is equal to n minus 2 and I is less, so not less than, we are traversing from last, no, I is less than 0 and I minus minus. Now first of all I will check while my top, like if my top elements, for example, okay, first of all I will implement that, then I will explain the procedure. So what I'm doing, first of all, while my st dot size is, sorry, st dot size is greater than 0, and if my stack dot peak element is less than or equal to array of I, then what I want to do, I just want to pop the elements from the stack, because I don't want, if the stack contains the minimum, like mean lesser elements than the present element, then I don't want that elements. So just I want to pop the elements from the stack. Then I want to check if my st dot size, if my stack size is equal to 0, then just no need to print, I mean just that result of I will be just minus 1. That's very simple. Or else what I want to do, I just want to do like result of I will be my st dot peak element. That's very simple solution. Now at last, for each and every element, I just want to push that into the stack instead of push is array of I. Yes, it's very simple solution. At last, I just want to return the result. Okay, let me compile. Okay, there is some errors. Let's find that error. Okay, just not initialize this I. Now I will run it. Okay, it is giving wrong solution. So what is happening? Stack size is greater than 0. Stack dot peak is less than or equal to area of I. Stack dot if my stack size is equal to 0, then just result of I is equal to minus 1. Else result of I is equal to st dot peak. Everything is fine. What happened? What I have missed? Okay, okay, sorry. So first of all, I want to insert this last element also. No? So that's what I missed. So array of n minus 1. Now it will work fine. Let's run. Yes, it's giving the right on output. Let's submit. So this is very simple solution. I will again explain it. Yes, all test cases has passed. Okay, so that's it about the solution. I will explain the solution by taking an example. Okay, let's test this using a simple example. So this is my array, given array. Now what I want to do, I actually have parallel, I actually have the resultant array also. Okay, what I want to do, I want to just traverse from the last. So first of all, sorry, initially I will insert the last element into the stack. First of all, what I want to do, I created a stack, then I just print the last one as minus 1, because the after 7 there is no greater element. and I'm just pushing the last element. Okay, that's fine. And now again, traversing from n minus 2 because the indexing starts from 0, 1, 2, 3, 4, 5, 6, 7, and 8. So 8 means total there are 9 elements. So n minus 1 element is 8 element. N minus 2 means I am traversing from 9 minus 2, that is 7th element, and 8. So first of all, what I want to check, I want to check whether my size is greater than 0, my stack size is greater than 0, and if the peak element is less than 8, so 8 does not meet that element. So I just pop this. And again, okay, there is no element. Now I will end the while loop and I will come if my stack size is equal to 0. Yes, my stack size is equal to 0. So I just print again -1 for this 8. Now I come here. 6. For 6 also, what, okay, for 6 what I'm doing, before going to 6, the 8 will be inserted into the stack because the class stack dot push. Now for 6, the peak element is not less than 6. So it will be there, it will come outside the while loop, then it will check if the stack size is equal to 0 or not. No, it is not equal to 0, then it will print the peak element, that is 8, then 6 will be inserted into the stack. Now coming to 12. What 12 actually does, so 12 checks whether, so or peak element is less than 12. So just pop it out. And peak element is less than 12. Just pop it out. Then stack becomes empty. So nothing element is there. So -1 will be printed and 12 will be inserted. That's fine. Now coming to 1. 1 is less than 12. So it does not remove, does not pop any element. Then the peak element will be returned, that is 12. That's fine. And again coming to 3. Also, sorry, 1 will be inserted. Now coming to 3. 3 is greater than 1, so 1 will be popped out. And 3 is less than 12, so it will not be popped out and the answer will be 12. And 3 will be inserted into the stack. Now coming to 9. 9 is greater than 3. It will be removed. 9 is not greater than 12, so it will be there and peak element will be the answer. And 9 will be inserted. Now for 5. For 5, actually 9 is not less than 5, so 9 will be the answer for 5. So 5 will be inserted. Now for 2. 2 is less than 5. So nothing will be removed. 5 will be the answer and 2 will be inserted. So my answer is 5, 9, 12, 12, 12, -1, 8, -1, -1. So let us give the custom input. Is there any option to give the custom input? One second. Sorry, there is no chance to give the custom input, but this is obviously the correct output for this. Okay, so this is about how can we find the next filter element. Okay friends, that's all about this video, and the coming up video is stock span in Java. Okay, so subscribe to my channel Quick Coder to get notifications about the new videos. Thank you for watching.